What's going on, guys? In this video we are going to see how to solve a second order homogeneous linear differential equation with repeated real roots. We know that this is a second order by looking at the double prime, and we know this is a linear by looking at the y power. Y power has to be 1 or 0, and we know this is a homogeneous because this whole thing is equal to 0. Okay, now whenever we have a second order homogeneous linear differential equation, what we do is we take the characteristic equation. Characteristic equation is whenever we have y double prime, we replace that one with r square. Based on the order, the power remains. Like if it's second order, the power is going to be 2. And if it's first order, the power is going to be 1. And if it's zeroth order, the power is going to be 0. Power 0 means it's just 1. So we don't have to put any r right here. We just put the coefficient in front of it. That's 9. Okay. The whole thing is equal to 0. Now we have to factor this one. If you factor this one, you will get r minus 3 square. This is equal to 0. So from this one you can see r is equal to 3 repeated. So this is a repeated real root. Repeated real root. So whenever we have a repeated real root, what we do is we write the general equation for the differential equation in this pattern. Y is equal to c1 and e power, we put this r right here in the power, multiply by t, and also we put another constant c2 and multiply this one by t and e power 3t. Okay, and also you can have distinct real roots. When you have distinct real roots, the only difference is you won't see this t right here. This one comes when you have repeated real roots. And if it's distinct real roots, for example, if you have r is equal to 3 and r is equal to 2, what you have is you will have 3 right here and you will have 2 in the power, but you won't have this t. You will have c1 and c2 alone. Okay, that's the difference between repeated real roots and also repeated real roots and distinct real roots. And also there's another one that is complex numbers. If you want to watch those things, there are a bunch of videos about that in my playlist. Go ahead and check them. I'm going to do some more of the repeated real roots. Here we have another one, y double prime plus 10 y prime plus 25 y is equal to 0. Y prime we replace that one with r square, and y prime we replace that one with 10. 10 is coefficient times r, plus we just put the coefficient for this one, that's 25 is equal to 0. From this one you can see the factor of this one is going to be r plus 5 square. This is equal to 0. Therefore r is equal to minus 5 repeated. So the general solution for the differential equation will be in this pattern. First we have to put a constant, e power, we put this one in the power and multiply that one with t, and c2 we have to multiply this one by t, and e power negative 5t. So this is the general solution for the differential equation for this one. Now let's look at another one with higher order differential equation. So for higher order also it will work. Let's see how it works. Here for higher order, y triple prime, if it's triple prime we have to put r cube, and if it's double prime we put 3r square, because 3 is coefficient 3, and double prime r square, and 3y prime we put 3r, and here we don't have anything, so we just have to put a 1 right here, and that's equal to 0 because 1 is coefficient. Okay, the whole thing is equal to 0. Now we have to factor this one. If you factor this one, you will end up with r plus 1 cube. This is also repeated because r is equal to minus 1 repeated, but this is little bit different because this one repeated 3 times. So the answer is going to be little bit different. Let's see how it's going to be. So first we will have y is equal to c1 e power negative 1t, then c2 we have to multiply a t, e power negative 1t, or you can just put negative t, and plus c3. Now we have to put a t square. So you can see as the order increases, we have this one 0, t power 0, it means 1, we don't see that, and this is t power 1, then t power 2. If you have one more, that's going to be t power 3. It goes like that. So this is c3 t square e power minus t, and this is going to be the general solution for this differential equation. And that's how we do the second order homogeneous linear differential equation with repeated real roots. And if you are trying to learn distinct real roots, complex numbers, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.